So here is the second half of the notes for piecewise functions. Okay, let's get right into it. So this first one, so we have the function g of x equals -5/2 x minus 1. Okay, so remember, let's just interpret what this means. Well, this means that for all x less than 2, we're going to use this function, and for all x greater than 2, we're going to use this function. Okay, so first things first, we graph each line. So we graph the line -5x minus 1, or y equals -5/2 x minus 1. Okay, so we graph this line that has a y-intercept of -1, has a -5/2 slope, which means we go down 5, 2, 3, 4, 5, and over 2. And we can do another point this way. Okay, now we'll use our straight edge to give us a nice straight line there. Okay, so this is the line that we have. Now we just need to figure out which piece of this line we're keeping and which piece of the line we're getting rid of. So we look at this and it says if x is less than 2, then we use this part of the function. So that's the part we want. We want for everything that's less than 2. So we come to 2. I'm going to cover up everything that isn't less than, so this is what I want. For x is less than 2, this is 2, 1, 1 is less than 2. So when x is equal to 1, we want that part of the function. Okay, so this is the function we want. And then we erase the part that we don't want. So we erase that part and we just want to go right up to where x equals 2. But for this one, we are not including 2 in it. It says for x is less than 2, but not for x equal to 2. So we're just going to go ahead and put an open circle right there. Let's see, actually our line goes right to this point right here. Our line goes down here, and at x equals 2, it's right here. There we go. We're going to put an open circle right there. Okay, so now we have that line graphed. Now we need to graph the other line, which is y equals x plus 2. Okay, so again, this has an intercept of 2 and a slope of 1. Intercept of 2, slope of 1. Okay, so we're going to graph that line, and we decide which piece of this line are we keeping. Well, we're keeping this line for everything where x is greater than 2. So we come to, again, x equals 2, and we take this line for everything this way of the line. We want to keep this line for everything greater than 2. But in this case, again, we actually don't want it to be equal to 2. We don't want to keep 2. It says for everything greater than 2, but we don't want to keep 2. So then we erase all the rest of the line that we don't need. We don't want this line all the way over here. We only want the line from where x equals 2 and greater. All right, so once you have your graph, then we just have to figure out domain and range. So again, we're going to use our ruler trick. We're going to say, okay, if I have my ruler way over here, am I going to be touching some point on my function? And I can look and I can see, well, this line goes forever and ever and ever. So I will always be touching some point on my function if I am over here. There's still a point on my function that has that x value. There's a point on my function that has all these x values. And I keep going and I keep going until I get right here to 2. And at 2, you'll notice this has an open circle and this has an open circle, which means that neither one of those include 2. So in my domain, there is not a single point on my function that actually is at x equals 2. There's none. Now there's a point at x equals 1 or x equals 1.999999, right up next to 2, but there is not a point at 2. So 2 is not part of my domain. But then if I keep going over this way, then I get again, on this line, forever and ever and ever, I will always be touching at least 1 point on my function. This side will always be touching at least 1 point because this line goes forever. So my domain for this one is all real numbers except x is not equal to 2. Now let's take a look at our range. If I come down here, am I touching any point on my function? Will I ever touch a point on my function if I'm this low? No, I'm not. I'm never, ever, ever going to be touching my function. My function only goes this way. It only goes up. So down here, there's no point on our function that has a y value less than this point right here. So this point right here is at y equals -6. So for everything bigger than -6, if I keep going, there's a point on my function that has a y value of all of those numbers that are greater than 6. But right at -6, there is no y value, or there's no point on our function. So our range is y is greater than -6. All right, let's graph this one. We graph these 3 lines, and then we figure out what, or we graph the first line, figure out what part we want to keep, and so on and so forth. Okay, so first we graph y equals -1. Now again, this one is a horizontal line at y equals -1, right? Because that has a slope of 0, intercept of -1. It's just a horizontal line. Okay. Now let's figure out what part of this line we want to keep. Well, this says for all x that are less than or equal to -5, I want to keep this line. So I take my paper and I cover up, let's see, 1, 2, 3, 4, 5. So at this point right here, I want to keep the rest of my line. I want everything for x is less than -5. Well, here's -5, and every number this way is less than -5. So I want this part of the line. I want to keep this part. And I want to keep at -5 I want to keep right there at -5. But I don't want to keep the rest of this line. I only want to keep this line for everything where x is less than -5. So I erase this part. All right, now let's take a look at the next line. So the next line is -x minus 3. So that has a -3 intercept. And it has a slope of -1, down 1 over 1, down 1 over 1. So we graph that line. And again, we want to keep this line from x equals negative, or x is greater than -5 and less than 1. So we want to keep it from, let's see, here's -5. Okay. And then, grab another piece of paper here. We'll cover up y equals 1, or x equals 1, sorry about that. So x equals 1. This is the piece of the graph that I want to keep. Okay, this is the piece that we're going to use for this one. We're going to keep this part of the line. And then we're going to get rid of the rest of the line because we only want to keep it in between -5 and 1. Now in this case, we don't want to include -5 and we don't want to include -1. So we're going to do an open circle here and an open circle here. We don't want to include those points. All right, and our final one to graph on this one is y equals 6. So again, this is a horizontal line. So we come up to y equals 6 right here. And let's actually just, instead of graphing the whole line, let's just start where we know we need to start. Okay, we already know that we're not going to keep this whole line, so let's just graph what we need. Well, that's for everything that where x is greater than or equal to 1. So we come on this line, we start at 1, and we go out this way. And we're including 1 because we said greater than or equal to. So we want to keep that part of the line. We don't need the line on this side because this is a piecewise. We only need the piece that we want. Okay, so now let's look at our domain and range. Again with your ruler, if I'm on my function and I'm right here, am I touching a point on the function? Yes, 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 even right here. Yes, I am still touching a point on my function. So for this value of x, where my ruler is, I have a point on my function. And for this value of x and for this value of x, for all of these values of x, there is a point on my function that has that value. Okay? And if I go forever and ever in that direction, I also do. So again, the domain of this one is all real numbers. And the range, we're going to do the same thing for the y. So we come up here, and we say, okay, down here, there is not a single point on my function that has that y value. Not one. So I just keep going, and I keep going, and when I get to this point right here, which is y is equal to -4, I don't have a point right at -4, but all the points above -4 I do. So right here at -4, I don't have a point on my graph. But then when I keep going, okay, now I'm touching my function, so this is part of my range, everything bigger than -4, and I keep going, I'm still touching a part of my function. This has lots of points, but that's fine. As long as I'm touching at least one point on my function, it's part of my range. So I get all the way up here to y equals 2. So in between -4 and 2, I have points on my function. So in between -4 and 2, see how we write it like that? It's in between -4 and 2. It's greater than -4, less than -2. I have points, okay? But right here at 2, I stop having points, and I keep going. There's no points on my function that are here. There's no points on my function here, no points here, until I get all the way up here to y equals 6. And then again, I have points at y equals 6. I don't have points at y equals 5.999, and I don't have points at y equals 6.00001. I just have points right at y equals 6. It's the only place that my function exists on this graph. So I say either my range is here, or we use the union symbol, y is equal to 6. At any of these points for y, you will find a point on my function. That's what our range means. All right, let's take a look at number 7. Again, we're going to graph these lines. Let's graph y equals 2x. Well, that has an intercept of 0 and a slope of 2. Now, if you're getting really good at this, let's just graph it from -2. Okay, so let's make sure that our slope, let's make sure we're really good on this. There we go. Let's figure out where this one is. Let's see, so we'd go down 2 over 1, down 2. All right, so at -2, my line is right there. See right there. So for all x values that are less than -2, everything this way, we want to keep our line. So you can just go ahead and graph that line right there. And then we don't want the rest of this line. We don't want to keep any more of that line. And we do want to close circle at -2 because we understand that this includes -2 by saying less than or equal to. All right, let's graph the next line. Y equals -x minus 1. See, it's commutative property. You can move those around so that it makes more sense to you. That has an intercept of -1 and a slope of -1. So it's just going down like that. And we want that one from -2 to 4. 1, 2, 3, 4. Perfect. That's where that one's going to go. All right. So we can just graph it. If you want to graph the whole line and erase like we've been doing, that's totally fine. But if you're feeling like you know how to just graph from one point to the next, do that. And in this case, this one says it's less than 4 and greater than -2, but not equal to, so we make sure we have open circles there. Make sure we understand that that one is an open circle. Okay? All right, and then anything greater than 4, for all x greater than 4, we're going to have f of x equals -3, which is just a horizontal line at -3. And that's equal to, right? Yep. So this is what our piecewise function looks like. We have three pieces. This one, and this one. Let's check our domain and range. If we take our ruler, I'm always going to have a point on my function at any of these x values, no matter how far over I go, there's always a point on my function because this arrow goes forever and ever and ever. So I keep going. Here at -2, I have a point on my function. Here at 0, I have a point on my function. All the way up through through +4, I have a point on my function. And I just keep going and going forever and ever. So there's always a point on my function for every x value. So the domain of this one's going to be all real numbers. Now the range, we're going to do the same thing. Check here. Yep, there's a point on my function. There's a point on my function. There's a point on my function. There's always, for these y values down here, there's always a point. The highest point that I can get to, though, here is +1. Y equals +1 right here. There's not a point right there. Everything below +1, I have a point on my function. But when I get to here, after that, I won't be touching any points on my function from then on, right? So all of my y values on this function are below -1. So my range here is y is less than -1 and not equal to, because that's an open circle. All right, final one. Let's take a look at this one. We're going to graph these. Y equals -3x. Well, that has an intercept of 0 and a -3 slope. 1, 2, 3 over 1. 1, 2, 3 over 1. All right, and for all x less than 0, we're going to keep this line. So let's just go ahead and graph that from x is less than 0 and on. Right, because I don't want to graph this part of the function of this line, because at x equals 0, we don't want to use this line anymore. So I just want to keep that piece of it. And this is going to have an open circle because we're not including 0. We want everything except 0. All right, now let's graph this line, -1 intercept with a -1/2 slope. So down 1 over 2, down 1 over 2, down 1 over 2. Okay, and we want that from x equals 0 to x equals 6. So we want to keep that in that interval, remember, between 0 and 6. So there we go to 2, 4, and 6. That's x equals 6 right here. So we want to keep it at this point, but then we're going to have an open circle at 6 because we're not including 6. We're including every value right up to 6, but not 6. So we have two pieces of our function so far, and finally we're going to graph this piece. It's got an intercept of -7. 1, 2, 3, 4, 5, 6, 7, and a slope of 1. Okay, and we only want that from x equals 6 and forward. So we only want values of 6 that are, or of x that are bigger than 6. So we're just going to graph that. This is x equals 6 right there. So we just want this line past that. We don't want any of this stuff. And we also don't want to include 6, so we're going to give an open circle right there. We don't want to include 6 in it. So here we have our three pieces. 1 piece, 2 pieces, 3 pieces. So let's take our ruler and decide where our domain and range is. If we come over on this side, forever and ever and ever in this direction, we will be having a point on our function. We'll touch our function with our ruler, right? And we keep going. And right here at 0, we're not touching this part of the function, but we are touching this part of the function, okay? So we keep going, we keep going, we keep going, and when we get to x equals 6, my ruler is touching x equals 6, and it's not touching a point on my function at all. See that? Because this is open and that's open. So at x equals 6, there is not a point on my function. There's not a single point anywhere on this function that has the value of x equals 6. Okay, but if I keep going and I keep going and I keep going, I'm going to have them past that. So I have all the numbers, every number that exists except for 6. So the way I write that is all real numbers except x is not equal to 6. Okay, then finally here's our range. Down here we don't have any points on our function, right? Our function doesn't go this far. So if I've got my ruler down here, it's not touching anything on my function. But when I get right here, it starts to have a point on my function right here at -4. And I keep going, and I keep going, and if I keep going, even right here, I have a point on my function. Right here, there's a point on my function. See right here on this line? That still exists on my function. So if x equals, like right here, or if y equals right here, there's still a point that exists on our function that has that y value. And then these lines go on forever and ever and ever, all the way up. So no matter what, I'm always going to have a value up high. So basically our lowest value is 4, -4. So y has to be bigger than -4. It can't be any less than that, but that's our lowest value. So I hope this helped a little bit, understanding piecewise functions. Just remember the steps. Number 1, graph the first piece of your function and decide what piece of it you're keeping. So graph this line and then decide what you're keeping. And then you graph this line and use this to decide what piece of that you keep. And then graph this line and use this to decide what piece that you keep.